In this video, I'm going to be working 2024 Calculus AB free response question number 6. This one's looking like it's got area and volume. To me, it looks pretty cool. So f and g are defined by x squared plus 2 and x squared minus 2x. So it's two different parabolas. Okay, oh, and I see the scale is kind of different on x and y. It's an interesting art here. Let R be the region that we can see between f and g from 0 to 2, right, but do not evaluate an expression that gives the area of region R. I think we're going to be able to do that. That's going to be integral of top minus bottoms. And it looks like x is running from 0 to 2. On top, I've got f of x. On bottom, I've got g of x. All right, so that one, that one looks good. I think we hopefully know what to do on that one. Let S be the region bounded by the graph of G in the x-axis between 2 and 5 as shown in the graph. All right, S is the base of a solid. For this solid, at each x, the cross-section perpendicular to the x-axis is a rectangle with height equal to half its base. Okay, so it's going to be a rectangle, and we're going to do our usual process on this. We know that because we're going perpendicular to the x-axis, we are going to be integrating with respect to x, so it's going to be 2 to the 5 of volume. Okay, now volume is going to need to depend on x because we're integrating with respect to x, but we're going to have to come back and kind of do some work here. I'm going to kind of just replicate region S. I could do a little better than that, I think. There. And then we're going to say, all right, the cross-section that's perpendicular to the x-axis, that's going to be the base of my rectangle. Okay, area, oh no, not v of x. Oh, that's embarrassing. Okay, well, but I'm not going to re-record the video. Volume is the integral of area, right? Okay, it wouldn't make sense to get volume equals the integral of volume. That would be kind of ridiculous. I need an area formula for this rectangle, and that's going to be base times height. Okay, well, base is going to be top minus bottom. So that's going to be g of x minus 0. And so I'm going to have g of x times height is half the base. Okay, so I've got g of x times 1/2 g of x, and that's going to be 1/2 g of x squared. Okay, that's going to be kind of a lot because g is a binomial, but that's all right. We're not scared of some algebra and calculus. So, right, maybe I'll do a little bit of this multiplication off to the side. X squared minus 2x, because it wants me to find the volume of the solid without a calculator, yeah. Okay, so x squared, negative 2x, negative 2x. This is maybe not quite enough room, but it'll be all right. X to the 4 minus 2x to the 3 minus another 2x to the 3 and plus 4x squared. So I'll have x to the 4. On x to the 3, I'll have negative 4 of those. Okay, but at least this will be decent to integrate. Okay, and that's what I've got. That's a of x. A equals base times height, which was 1/2 g of x squared. All right, so I'm integrating from 2 to 5 on, I'll just hold the 1/2 off to the side, x to the 4, negative 4x to the 3, and that was supposed to be a 4x to the 2, right? Yeah. All right, and now I'm going to do power rule. Oh, yeah, let's just get rid of that so nobody would be confused. And this is just scratch work, so we don't even really need this. And I'm going to go, say, okay, 1/2 of 1/5 x to the 5th, and we really need to show that antiderivative because that's probably going to be one of the points on this problem. From 2 up to 5, and okay, volume is going to equal this, and that's going to be 1/2 of, when I plug in 1/5 of 5 to the 5th minus 5 to the 4 plus 4/3 of 5 cubed. That's pretty rough as numbers go. Minus, I guess, 1/2. I'd have to distribute that in because I wasn't able to fit it all in one line. Maybe I should, though, because that's just like the type of thing that's asking to be a linkage error, and I've been trying trying to get my students in my class to be more cautious about that lately in recent years. So I'm just going to go over here and say, all right, really, I'd put that one big thing so I could plug in 5, plug in 2, subtract, and not really have to simplify. And I think that's definitely the way to go, especially on this problem. This is a really bad number. I mean, maybe there's some sort of arithmetic trick I'm not thinking of here where we could actually find the volume of the solid and make it look nice. Is a rectangle with height equal to half its base? Yeah, that's going to be 1/2 base squared. Yeah, it's equivalent to an isosceles right triangle, it's just the shape of it's going to be very different. Okay, well, that one was interesting. Part C is going to be telling me to write and not evaluate an integral expression that gives the volume of the solid generated when S is rotated around y equals 20. All right. Very rough sketch of S, very rough sketch of y equals 20. Okay, S was bounded by g of x and 0 from 2 to 5. Y equals g of x and y equals 0. Okay, I'm going to need a large radius and a small radius. So my large radius will reach from the axis of rotation all the way to the far edge of region S. I might call that A. The small radius will be B. Or maybe in this case I'll call it A1 and A2. Because I already wrote B earlier in part B, so I'll just say A1 and A2. That'll be fine, and that'll be different from the area that I did in part B. I don't think anybody's going to be upset about that anyway. But A1 is going to be top minus bottom, so it's going to be 20. Y equals 20 minus y equals 0, so it's going to be 20. And then A2 is going to be top minus bottom, y equals 20 minus y equals g of x. Okay, so that's just going to be 20 minus g of x. I don't really have anything I can do with that to simplify. But volume, when I'm rotating, and when there's going to be hollowness, which I can see there is because 20 is way above the top of, well, is it? Yeah, 20 is way above the top of S. So it's still going to be the integral from 2 to 5 because I'm rotating around a horizontal axis that looks like the x-axis. So it's going to be large radius squared. And if you are like really explicit about A1 equaling 20 and A2 equaling 20 minus g like I was, you might could write A1 squared and A2 squared. But I think, if it's my AP exam determining whether or not I get credit for the course, I'm going to just fill this stuff in just so that I'm not going to get caught up by like some super strict grading rules or anything like that. And there you go. I've got myself a volume set up for the washer volume. Yeah, volume of the solid generated when S is rotated around y equals 20. All right, so that is free response question 6 for a 2024 Calculus AB. So that'll be all for this video. Thanks for watching.